This is the Climate Academy Systems Understanding course, and this is Chapter 8 on physical tipping points. This chapter is about when physical Earth systems flip and they go into a new state, and that change is abrupt, it's irreversible, and it leads to cascading consequences. Now, this video might have the same effect on your understanding of the climate crisis. Understanding tipping points is possibly a threshold concept for you. Once you've understood what a tipping point is, it transforms the way in which you understand all the other details of the climate crisis. So it's really a key fundamental chapter. It's Chapter 8, and we've already done some of the groundwork. We've been working our way through this. We've gone through the absolute basics. We looked at carbon budgets, and in the last chapter we looked at how close we were to these tipping points. But now we get to look at what those tipping points are in detail. So this is the Climate Academy course. Everything which I'm going to say, of course, it can be found in here. It also can be found in the Moodle. And when you've finished listening to this chapter or reading this chapter, you go in the Moodle, you can do the quiz, or you can go into the Explore section and find out more. But let's get going. What is a tipping point? What is the most important map in the world? Well, I suppose if you're on the London Underground, then the tube map would be the most important one to make sure you get to where you want to go. If you're in the Highlands of Scotland, you might want to have an ordnance and survey map so you can get home. Or if you're in a building and there's a fire, it's probably quite important to know where the fire exits are on those little plans of the building. Now, in terms of climate change, what's the most important map? Well, I'm going to argue that this one is. This is a map of the different Earth systems that are in play. So when you look at the map, you can divide this map into three types of components, three elements. In the blue, you have cryosphere stuff. So cryo, that's the word for ice. So at the bottom, you can see the West Antarctic ice sheet. At the north, you can see the Arctic ice, and then the Greenland ice sheet. You also have glaciers around the world in the mountains. And then you have the red zones, and these are to do with circulation patterns. So you can see, perhaps most famously, the jet stream, which curves its way across the northern hemisphere. You have the monsoon, Indian summer monsoon patterns, and the El Nino oscillation. And we're going to look in a little bit of detail at the AMOC, which is in the middle. That's the Atlantic thermaline circulation. And then finally in green, you can see the biosphere Earth systems. So this is the forests in the Amazon, in the boreal forest in the north, and also the tropical reefs around our world's beautiful oceans. This is the most important map you'll see today, arguably this year, because this is the map which gives us the picture of life on Earth. Human life is possible because of these fundamental components, these fundamental cogs in the great clockwork of the planet working. So if we disturb these cogs, if we throw them out of rhythm with each other, then we're disturbing a dance that has been going on for millions of years and has settled into a very deep equilibrium. And humans, by doing abrupt, rapid climate change, by burning fossil fuels, it's like putting a stick inside a wheel of a bike when it's going fast. And the consequences of that would be catastrophic. And I don't just mean bad or damaging, I mean catastrophic. So all of these systems that are in play interrelated with each other. This is what forms the basis for all of our economies, all of our future ambitions, and we cannot mess with it. And yet, weirdly, very, very weirdly, if you go in a geography textbook in a school, you go in a chapter on climate change, is this map there? If you interview students coming out of school, graduating when they're 16 or 18, and you stop them at the school gate and you ask them to identify this map, how many would know what it is? And is that not completely wacky? Do we allow students to graduate from our schools only with a vague idea of who Hitler was? Would we allow our students to graduate from schools thinking that Colgate was a good contraceptive? By the way, in the Philippines, with the lack of a proper sex education program, you can find very strange ideas about Colgate. No, we would not allow that. This is reckless. So climate change, although we talk about it a lot, what is missing, one of the key threshold fundamental concepts, is tipping points. We have millions of students every year that graduate from school and they have advanced skills in maths, they have advanced skills in physics, biology, chemistry, they are brilliant musicians, artists, historians, etc. And yet, so many of them don't know what a tipping point is. And I don't just say this off the top of my head. The Climate Academy students in Brussels, we're going around Europe at the moment, and we're surveying schools and the public about their knowledge and understanding of tipping points. The results will be out in about a year's time from now. And so far, we had over 1,500 data points. The results are not good. So few people are able to define a tipping point or explain what one is, or give a good example of what one is. And almost nobody can do both. And that is a very dangerous level of illiteracy. And it's not just the general public. It's not just school students who are limited in their understanding of tipping points. I'm going to play you a clip in a minute from the BBC. This is Radio 4. It's their flagship. It's called Intelligent Speech. And in the morning, I was listening to Radio 4 over my breakfast, and Justin Rowlett was being asked by the hosts of the programme why 1.5 and 2 degrees matter. Why does temperature rise matter for humanity? So Justin Rowlett is the BBC's climate editor. He's an Oxbridge graduate. He's a mature man of years of experience in this subject. So the BBC, symbolically, one of the best, and it has many qualities, but on climate, it's rubbish. And here's the example. So in this extract, I was so astonished, I choked on my cornflakes. I put down my spoon and I recorded it for prosperity. So listen, he's asked the question, why does 1.5 or 2 degrees warming matter? And his answer should be because that takes us into a minefield of various tipping points. But what was his answer? His answer was, it leads to more extreme weather events. It's not incorrect to say that 1.5 and 2 degrees causes more extreme weather events. It does. But those are just the symptoms at the surface level. The reason why it matters, the fundamental reason why that temperature matters, is because of the pressure that it puts on these underlying Earth systems. That's the answer. in a hospital, if you go and visit a sick relative and you ask the doctor, what's the matter? And they say, well, they've been coughing this morning, but they don't tell you that they have cancer. That's a bit misleading. Now, the coughing might be a symptom of the cancer, but at some point you have to talk, and I think the first thing you should say is what the fundamental problem is, and then you can talk about some details. But to not talk about tipping points when you're directly asked, that question is a big misstep. That is shocking. That is a shocking level of climate illiteracy from one of the most prestigious and supposedly educated programs in media, in global media. So from the top to the bottom, we have a dangerous blind spot in climate literacy, and it's on tipping points. Here's the clip.
Above pre-industrial levels. Their new assessment at the beginning of 2025 is we've got 130 billion tonnes. We emit about 40 billion tonnes a year. So the maths is fairly straightforward. 3 times that gets you to 120. So you're almost at breaching the limit in 3 years' time. So yeah, it's a very stark and worrying warning from these scientists.
Final, very brief thought, Justin. What happens once that limit's breached? Why is it an important threshold?
It's an important threshold because it was recognised that beyond 1.5 there would be more extreme weather events. So the climate change would be harder to cope with, would be more of a challenge for the world. It's not an absolute boundary, but it's a recommendation. We should do our best to stick to it because it will minimise the damage to the Earth. But what the scientists are saying, listen, every degree matters.
Yeah.
We shouldn't take our hands off the, stop making an effort to reduce emissions.
Carbon
we should
emissions as soon as
continue
we
to
can.
do so because every fraction of a degree really counts.
Justin Roller, thank you.
So what is a tipping point? Well, let's put some keywords out there. A tipping point is a critical threshold where irreversible, abrupt change in a non-linear way takes place. It triggers feedback loops or runaway effects, or you call it the domino effect or cascading effects. And this leads to an amplification of the disturbance. Tipping points and the Earth systems are also profoundly interconnected. So the Amazon rainforest, of course, is linked with the AMOC. So one tipping point would lead to cascading effects in other Earth systems. And fundamentally what happened after a tipping point is you have a state shift. You have a loss of stability. So these are the key words which define what a tipping point is. But maybe it's helpful to visualize this. Here are some lines. A blue line, purple line, and a red line. Now, in the blue line, you can see that the dot has got quite a safe operating space. So it can move around, but it's not going to go outside of those borders. It's well entrenched, it's well embedded in a situation. Now imagine these 3 lines represent relationships. In the blue relationship, a good relationship, there is forgiveness. In a good relationship, there's reconciliation. You're allowed to make mistakes in a blue relationship. There's margins of tolerance and there's give and take. And things are stable. It's not like one small incident is going to make that little ball just fly out. So you have in that blue line a kind of representation of an Earth system which after millions of years, and because its neighbours are also stable, you have basic stability. But if we go to the purple line, you can see there that to the right, the shelf is a lot lower. So a little bit of movement now from that ball and it might just go over that hump and into a completely new state. So this is a weakened system. If we go back to relationship, perhaps in a relationship, one of the people in that relationship has done something which has severely damaged the relationship. So therefore, even small provocations or reminders of that incident or that damage gives kind of a vertiginous feeling, like, oh, but where are things going to go now? Like we're in unstable territory. So in the purple zone, this is like Earth systems which are getting destabilized. They're still stable. They're still together. It's still coherent. But now the margins for tolerance are diminished. Patience is running thin. And finally, the red line. In the red line, things have been thrown out of an equilibrium. Now we're in a completely new state. The old paradigm, the old set of beliefs and assumptions, the old set of commitments, let's say, in that relationship are gone. And there's no recovery. That ball is not going back. There's nothing to go back to. There might be a sort of memory of the previous state of affairs, but this is now finished. So again, one last time, if we translate our relationship metaphor into Earth systems, these are Earth systems which have gone over a critical threshold. They pass beyond a point of no return, and we have non-linear change. We have irreversible change to an ecosystem. So that's a visualization of tipping points. And I have one more final visualization, and this comes from a velodrome. So in this velodrome, you can see, and you can YouTube, there's lots of rather terrible accidents. If you're in a macabre mood, you could YouTube this. In a velodrome, you could sometimes have accidents, and they lead to serious damage to the people involved. And you can notice in these velodrome accidents that it all starts with a small glitch, like there's a little movement. And this small thing, maybe it's a chain coming off, maybe it's somebody just turning too fast on the corner, but that small event has cascading effects on the peloton or the pack of bikes which are around it. So that's quite a nice metaphor for how these Earth systems work, in that small changes can lead to dramatic consequences. Which tipping points are close? Well, let's go back to the map. You could line up the different cryosphere systems or circulation patterns or biosphere elements, and you could line them up and rank them according to which ones are going to tip first, because each one of those systems has a higher or lower tolerance or built-in, let's say, defense mechanisms to disturbance, and some systems are more fragile than others. So let's start with the coral reefs, because these systems are basically already tipped. They're already gone. Now, I know that if you were to visit the Great Barrier Reef in Australia, you would still be able to see some beautiful coral reefs. But this is a bit like watching a football team towards the end of a season, which still has to play its football matches because that's on the schedule, but mechanically, technically, mathematically, they're going to be relegated. In England this year, that's true for Wolverhampton Wanderers. I'm sorry for any Wolves fans out there, but in 2026, that's the season in which you were relegated. There's no way they can recover. Even if they were to win all of their games in hand, all of the remaining matches, they would still go down. So the coral reefs are kind of clinging on to the last fragments of life as it's possible, but the oceans are too acidic and the temperatures are too high for that to carry on. Now, with all of these things, there's always margins. So science understands these systems very well. Biology understands coral reefs profoundly. But because it's a complex system, there is no absolutely definitive number for when that system would collapse. But we have between 1 and 1.5 degrees, and scientists essentially think that within that margin, they think that 1.2 is the central point of their estimations. Now, as you know from previous chapters, we are already at 1.4. So the coral reefs are not going to get better because our temperatures are not coming down anytime soon, and this is way beyond what the coral reefs can tolerate. So that's our first tipping point. That's our first ecosystem which is going to collapse. Let's have a look at a very helpful graphic. This is taken from the Global Tipping Points report from 2025. So in this graphic, you can see those coral reefs that between 1 degree and 1.5 degree warming, we think that the coral reefs are going to die off. Now, if we take a step to the right, there you can see the West Antarctic ice sheet. And just like the coral reefs, this is already in play. We're already destabilizing the West Antarctic ice sheet and the Greenland ice sheet. And in fact, some scientists have already concluded that it has already gone over a tipping point, that it's already gone beyond an irreversible point. Now, the timescales for the collapse of these ice sheets is quite long term, but let's just point at the amount of water involved. These are big blocks of ice. The Greenland ice sheet contains between 7 and 7.5 meters of sea level rise, and the West Antarctic ice sheet contains 3 to 5 meters of sea level rise. So altogether between 10 and 12 meters of sea level rise. Now, that is a game changer for human civilization. If those ice sheets disappear into the sea, then all of those cities which we have built on the coastlines which we inherited from a stable environment, they will have to move. And the cities involved in this are very significant cities. New York, Shanghai, Osaka, Amsterdam. In fact, there was a report in The Guardian a number of years ago about which cities become uninhabitable at 3 degrees. And 3 degrees, it's absolutely sure that those ice sheets are gone. So at 3 degrees, which cities would be gone? And this graph shows you just how many millions of lives would be displaced by those sea level rises. And it's not necessarily that those cities go underwater. The destabilization to human civilization here is just flooding, which becomes so consistent, so perpetual, so damaging. No insurance company is going to give you anything to rebuild. I mean, many years ago, New York suffered terrible floods and the whole subway system suffered millions of dollars of damage. You can't have that happening every 3 years or every 5 years, so that effectively becomes undoable. So whole cities will be wiped off our registers as human civilization, including all the culture, all the memory, all of the lives that are there, if we have sea levels of that significance. And we have already, in that graph, we've already destabilized those ice sheets. We're already into a destabilized situation. Let's shuffle over to a very significant circulation system, and this is the AMOC. This is the Atlantic Meridional Overturning Circulation. So what's happening here is that in the Atlantic Ocean, warm water is traveling north on the surface of the Atlantic, and at the same time, cold fresh water melted from the glaciers is heading south in the deep ocean. And this tumble dryer type system is controlling weather patterns, and it's controlling marine life, and it's like it's like recharging your phone in terms of the oxygenation of the oceans. And just to give you a sense of the scale of this, every second 17 million cubic meters of water is being moved by this system. So it has a huge significance for the planet. In fact, the AMOC is the most interconnected of all of those Earth systems. It's connected to the Amazon. In fact, in this graph here, you can see all the different systems that it's connected to. In total, there are 45 of them. Now, because of climate change, this circulation pattern is slowing down, and this has huge implications for Europe and the rest of the world, but especially Europe. Have a look at this graphic. Here you can see that Britain, Scandinavia, they would suffer a decline in temperature of between 3 and 5 degrees. So it would actually get a lot cooler, whereas and wetter, and the storms would become much more intense. And in the green zones, these would become hotter and drier, dramatically so. So then you're going to have water supply shortages. Now, this will have an absolutely crippling effect on food supply. And this is just Europe. Given the scale of the threat of a collapsed AMOC, given its proximity, because in that graph you can see that it's already in play, it's already slowing down, and it's likely that by the end of the century, on current pathways that we're on in terms of emissions, it will stop. Given the proximity of this danger, you'd think that it would be in the news a lot. It isn't. What do we get in the news when we have climate change reported? What we get is climate news when there's an extreme weather event. Just like Justin Rowland and the BBC, that's all of our framing of the climate crisis. It's all about individual, tactile, sensory weather events. So when we are invaded by an extreme weather event, we can't ignore it. A flood, a drought, etc. But we're not capable, weirdly, oddly, of looking square at these threats that are, in a sense, more abstract. But my goodness, they are real. They're not abstract threats. So one last time, let's go back to the graph and to the end of the graph and the Amazon forest. So you can see there that at 1.5, it's not good. 1.5 sustained over a very long period of time, especially if you're doing deforestation, destabilizes the Amazon rainforest. And at 3 degrees, you're almost sure that the Amazon is going to collapse. Now, in terms of the big picture, the Amazon rainforest collapse, the AMOC collapse, these are not insignificant details of climate understanding and climate change awareness. These are this is what it all comes down to. Tipping points is where the real action of the climate crisis is taking place. The Paris Agreement, the reason why we have a 1.5 preferably, or certainly not over 2 degrees, it's all because of tipping points. It's all because humanity cannot afford to put so much stress on the Earth's systems that one critical cog collapses. Now, a terrific book which lays out all of these tipping points in graphic detail, is very readable, is Mark Linus's 6 Degrees. It's been recently updated. Again, I put it in the Explore section. Now, this book takes you through a 1 degree rise, a 2 degree rise, a 3 degree rise, a 4 degree rise, a 5 degree rise, and a 6 degree rise in 6 chapters. It's 6 chapters of full explanations with all the necessary qualifications. You know, I'm speaking fast here and giving you a sketch of the main overview, but it's important to look at and study the science of it. So that book's a terrific introductory way into this topic, and it just takes it chapter by chapter, degree by degree. What is non-linear change? Well, let's start with what linear change is. If you get paid 10 euros an hour for chopping vegetables, then it's pretty clear to you that after 4 hours you're going to get 40 euros. If you're watching a match and your football team is winning 1-0 at half time, you have an easy sense of just how long they're going to have to hold on to that lead to go through to the next round in the cup. So linear change is predictable, it's intuitive. Now, the next gear up from linear change is exponential change. So this is change with a curve. This is change with a more dramatic upswing. A classic example of exponential change is the story, fictional story of course, of the Indian king who was gifted a chessboard by somebody, and he said to the guy who gave him the chessboard, well, what could I give you in return? And the man said, oh, simple, just give me a single grain of rice on the first square of the board, 2 grains on the second, 4 on the third, and so on. Now, this seemingly modest request was accepted by the king, but it turned out quite impossible to fulfill because the 21st square on the board required over 1 million grains, and the 41st square on the board over 1 trillion. And there was simply not enough rice in the world to properly fulfill the 64th square. This is exponential change. It's much more significant. In the Climate Academy student book, I go through 3 different types of change. So not just linear change, not exponential change, but in fact chaotic change. And this chaotic change again is a different magnitude of change, a different order of change, and Thijs is going to read an extract about that. And that type of change is what is in play with climate change tipping points. A chaotic change, an abrupt, non-linear feedback loop amplifying kind of change. Why are tipping points not a central feature of climate education and media coverage? Yeah. Why? This is extraordinary. It's a remarkable blind spot in our climate awareness. And as I mentioned in previous questions, it is something to do with us just being sensory creatures. Extreme weather events hit us in our senses. Extreme weather events are visual. They have an immediate impact. They're clear. Whereas tipping points are abstract, they're in the future, and they're also intimidating to think about. These are existential questions for humanity. But just because they're existential and difficult doesn't mean that we mustn't talk about them. As I've repeatedly said, we don't skip over the Holocaust because it's difficult to look at. We don't stop doing sex education in schools because it might be a little bit awkward. Some things you just have to do, and you have to find ways to do it. Now, I do think there's a case to not talk about tipping points with very young children, just like it's not appropriate to tell a 5-year-old that Father Christmas is not real. But from a certain age, from teenage years onwards, Surely this is just some absolutely basic knowledge about the world which every voter, citizen, consumer has to understand to frame their life by and to frame their decisions by. But let's have a little deep dive into the psychology. And this deep dive is an anticipation of what's going to come in later chapters in the psychology of climate change. But we're just going to have a little dabble for now in the psychology of all of this. And I'd like to introduce you to Tim the turkey. Tim the turkey lives on a farm. And the farmer comes out of his house every day with a bucket of grain, and he shakes that bucket of grain, he opens the gate, and he puts the grain on the ground, and Tim the turkey gobble, 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 happily eats the grain. This happens on Monday and Tuesday and Wednesday. In fact, it happens every day, every week through January. Farmer comes out, bucket of grain, rattles the grain, opens the gate, feeds Tim the turkey. It's February. The same thing happens. Tim the turkey hears the door, he hears the bucket, he hears the gate, he gets fed. It happens in March, it happens in April, it happens all the way through the summer months, and it happens into the autumn. And Tim the turkey is now happy and comfortable in his little routine with his farmer. It's now December. Tim the turkey hears the door, he hears the bucket, he hears the gate, and he gets fed. But now it's December the 23rd. And we all know that the farmer has got other things on his mind today, but Tim the turkey doesn't. Tim the turkey thinks it's a day like any other day. The door opens, he hears the bucket, he hears the gate, but today there's no meal for Tim the turkey. Tim the turkey is the meal. Now, I can't remember where this story comes from, but it's a fantastic illustration of the fact that just because events in the past have happened, it doesn't guarantee that they'll happen in the future. In fact, the philosopher David Hume talked about this in his empirical philosophy in the 18th century. Now, by the way, David Hume didn't talk about Tim the turkey, that's my little story. But the fundamental philosophy about how future events don't always have to match the past is an important one. Because as human beings, we have become accustomed to our planet providing us with a fantastic environment, a stable, warm Holocene. And it's really difficult for us to imagine that it can be different. It's very difficult for us to imagine that the Earth could become hostile to us, could become hostile to human civilization and our plans. But that's not to say that it's not possible. And in this sense, I think we could consider the oceans. The oceans up to now have been like a massive shock absorber for all the extra heat energy which we've pumped into the system. The oceans have taken it for us. The oceans have been our best friend, a bit like the farmer. But if we push the oceans over a tipping point, either like with the amok or like with the coral reefs, with the acidification, there are different layers to life in the ocean. If we stop the ocean becoming a carbon sink and we transform it to becoming a carbon source, well, we need to be asking what kind of sauce is going to be on our meals, because we're cooked. So Tim the turkey is our little deep dive, and I think it illustrates our difficulties in trying to understand tipping points because they are so big and we have no experience of them. They're not yet tactile to us. Now, if you want to know more about Tip the Turkey, you can jump ahead to the chapters on psychology, or I actually did a series on the philosopher Nietzsche, because Friedrich Nietzsche, he is a philosopher, but he's also a tremendous psychologist. And I've done a set of videos on Nietzsche on the psychology of climate change. And some of the things which Nietzsche says are very helpful in terms of diagnosing our inability to look at some of these existential things. So you can check that out. That's on my YouTube channel. So there's the end of the deep dive. It's a little dabble into the psychology of why tipping points are not a fundamental feature of school, education, and media coverage of the climate crisis. What is the precautionary principle? The precautionary principle is a risk management idea or principle for people in public office. And it essentially says that where there is scientific evidence of a risk which is potentially catastrophic or deadly or seriously dangerous, then your policies should reflect that. So you should be risk averse. You should step backwards from the risk, because even if you don't know fully all the scientific data, even if you don't have an absolute clarity on the situation, the precautionary principle says you still have to take it seriously. So where there are ambiguities in climate science, I mean, these are acknowledged by scientists. I mean, science is always a tentative discipline. Science is always modest in its conclusions. So even if that is the case, even if there are some ambiguities, even if we don't know exactly the temperature which would trigger tipping point A or tipping point B, we should adopt the precautionary principle, because the risks involved are too great. Now, our modelling of climate systems and Earth systems has developed remarkably over the decades of scientific research. We've known about climate change since the mid-19th century, but in recent years we really have become very deeply aware of the different dynamics, mechanics, and we have massive data sets to help us make reliable predictions. In fact, James Hansen, a former NASA scientist, he said that we now know as much about climate systems as we do about human bodies and diet. So it's clear that if you had a diet for 5 years of only eating Mars bars, then you would not come out the other side. Your body needs vitamins. It needs nutrients to survive. So that's just clear. And it's the same with climate change. There are some things which are just evidently, self-evidently clear about what is happening. But just like with a diet and just like with nutrition, at a deep level, there are many ambiguities because the human body is a complex system, just like the planet is one massive complex system. But the precautionary principle simply says that even though we don't have an entire understanding of an issue, you should be risk averse in your decision making, because pushing, in the case of climate change, pushing our systems over a tipping point would have just catastrophic consequences. Can small things make a big difference? They surely can. Let's just think about climate change. The amount of greenhouse gases in the atmosphere, the concentrations which we have at the moment, which are over 420, they are 420 parts per million. So that small amount of CO2 or CO2 equivalent has a massive thermal impact, a massive heating effect on the planet. So small little CO2 particles can cause havoc with human civilization. And to finish this chapter, let's just zoom in on the work of Paul Crutzen. So Crutzen, professor of chemistry, he won a Nobel Prize for his work understanding the ozone layer. Now, the ozone layer is a completely separate topic to climate change. The ozone layer is another one of those important planetary boundaries. And Crutzen made a discovery in the 70s about the chemical dynamics of ozone in the atmosphere and the fact that CFC gases were destroying the ozone layer, and it created a big hole in the southern hemisphere around the Antarctica. And this was extremely dangerous because although ozone only makes up 0.00006% of the atmosphere, it blocks out 98% of ultraviolet radiation. And if that ultraviolet radiation was allowed to pass through, if we didn't have this protective film of the ozone layer, then those UV rays would mangle our DNA. It would have such an invasive, destructive effect on all biological life, including us. And so Crutzen and his fellow scientists understood the significance of the ozone layer and the significance of releasing CFCs, which were damaging it. Crutzen and his colleagues made their discoveries about the ozone layer and CFCs in 1976. And just 11 short years after that, the international community had got together and everyone had signed up to the Montreal Protocol in 1987. This agreement banned the release and use of CFCs into the atmosphere in a binding legal document. So a wonderful success story of a combination of science and politics, something which COP has got a lot to learn from. So Crutzen won the Nobel Prize for his work and is a distinguished scientist. But to finish this chapter, I just want to zoom in on one little detail which is not often talked about, and that is that humanity, when we started using CFCs for fridges and aerosols and things like that, there was another chemical which was possible for us to use, and that was its little cousin, BFCs. And the difference between BFCs and CFCs, practically for the industrialists who are making fridges and stuff, wasn't that significant. It's just that CFCs were a little bit more convenient, and so we went with CFCs. But history could have been very different, or our future could have been very different. This is a monumental junction in human civilization, which many people don't know about, because if we would have gone for BFCs and not CFCs, then the hole in the ozone layer would have been blown to pieces well before we would have had any chance to recognize it or do anything about it. And it would have had an absolutely catastrophic effect on human civilization. So we looked out. We looked out. We just chose C and not B. And it wasn't because we knew what the consequences were going to be. So small things can make a big difference. Small chemicals in the atmosphere can have a massive impact. We've come to see that small changes, small nudges to the system if they happen over long and sustained periods of time, they can in the end lead to tipping points where one small change actually triggers irreversible, cascading, deep, non-linear, abrupt, dramatic, profound change. So this whole chapter has been about physical tipping points. And looking ahead, chapter 10 is about social tipping points. And here it's more positive because the same dynamics are in play in social systems just as they are in Earth systems. And because we're conscious, because we have reason, because we are scientific, because we can be literate, because we can be reasonable, we can, if we put the right energy and the right efforts into leverage points for social systems, we can achieve similar massive results. So small changes in consciousness, in climate awareness, or small groups of pressure on legal systems, these leverage points in our social systems can also lead to very dramatic changes, positive changes that can get us out of this crazy crisis. So that is the end of chapter 8 on physical tipping points, and everything which I've said can be found in here. This can be found inside Moodle, and once you've listened to me and once you've read the text, either or, you can go to the quiz, and in the quiz there's 10 questions taken from a random bank of questions each time, and you answer those questions and you can add another brick in your wall to achieving a Climate Academy Systems Understanding Bronze Certificate.